Hello everyone, in this video we're going to talk about compound interest rate. We previously talked about simple interest rate. So compound interest rate is an interest that is computed on unpaid balance. And an unpaid balance is composed of two pieces. First is the principal, and the second is the unpaid balance from the preceding periods. And this second piece is the key difference between compound interest rate and simple interest rate, because in the compound interest rate case, any unpaid interest from the preceding periods are subject to interest. And in the simple interest rate, that was not the case. In the simple interest rate, the situation is that you only apply interest on the principal money that was borrowed. So you can think of this as interest on top of interest. And it's a common way of calculating interest in practice. And that's in future, when we talk about interest rate, we're referring to compound interest rate. To make a better sense of compound interest rate, we're going to look at the same example that we looked at in the simple interest rate case. You've agreed to loan a friend $5,000 for 5 years at a compound interest rate of 8% this time. How much interest will you receive from the loan? And how much will your friend pay at the end of 5 years? That's essentially what the question is asking. If you remember, in the case of simple interest rate, the money that will be in the account at the end of 5 years would be, let's call that F, would be the principal, which is the 5,000, plus the interest that you gain on the principal, PIN. So that means $5,000 plus 5,000 times 8% times 5 years. And that adds up to $7,000. So that was the simple interest rate case, right? But here we're talking about compound interest. So we're going to look at the difference here. And to do that, we're going to track the money year by year over 5 years. In order to do that, we're going to create a table here. And the first column would be the period, which is essentially year. And that means from year 1, 2, 3, 4, and 5. And in each year, we're going to look at the beginning balance and then interest due at the end of that year, and then ending balance. Ending balance. Essentially, beginning balance plus the interest due will be equal to the ending balance at the end of year N. The end of year N. So let's start. We're starting with $5,000, and in year 1, the amount of money that will be charged as the interest would be 5,000 times 8%. That means $400. So the ending balance would be 5,400. So now, beginning of year 2, the beginning balance is the ending balance of year 1. So we're going to have 5,400 as the beginning balance of year 2. And then in year 2, the interest will be applied on this balance. So 5,400 times 8%, that is now $432. That makes the ending balance 5,832. I'm going to keep repeating this process until the end of 5th year. And now the total amount due at the end of year 5 is about $7,347. So that is the total amount due at the end of year 5. So that's the money that your friend is going to pay you back. And if you compare this money right here with the simple interest rate, which was up here, you see that there is $347 more. And that's the impact of compounding. That's the difference. So now you understand what the how compound interest rate works. What we're going to do is to, instead of this numerical example, we're going to create the same table, but this time is with parameters. So we're going to call $5,000 P. We're going to call 8% I, and so forth. So we're going to create the same table here. So I'm going to create that table here for you quickly. So this is the table that we had in that example. Now, what we're going to do is to fill out this table with parameters instead of numbers. So you see the years are starting from 1, 2, 3, goes all the way to a hypothetical year N. So we're starting with P, which is the principal, plus the interest for that year is just I times P. So the ending balance would be P plus IP. And that is, can be rewritten as P times 1 plus I. So now P times 1 plus I goes to the beginning balance of year 2. So P times 1 plus I. And now the interest on that is I times P times 1 plus I. So the ending balance would be P times 1 plus I to the 2. I'm going to finish this table right here for you. So now you see the pattern and what's happening. So in year N, what we're going to have is the beginning balance would be P times 1 plus I to N minus 1. And then the interest would be I times that. And the ending balance after N years would be P times 1 plus I to N, right? In other words, we started with P as the present sum of money in year 1, and then that became P times 1 plus I to N after N years. So we call this P present value, and we call this future value, right? It's the future value after N years. And we call this future value, show that with F. So the key formula that we have is that future value, F, is equal to P, present value, times 1 plus I to N. And that is the basis of what we're going to talk about from now on. So if you want to double check this formula with the previous example that we had here, F is equal to 5,000 times 1 plus 8% to 5. If you do the math, you get the same exact future value. So this is the key formula that we have. And here I summarize that for you. Future value, same formula. And you can rearrange this equation for P. And that becomes P is equal to F times 1 plus I to negative N. These things here, they're called compound interest factors. And there are tables at the end of your book that essentially lists these factors for you for different I's and for different N's. Because this part of the formula can be calculated for different interest rate for different years and then can be used in any example. If you have the P, you can always read these factors from the table or use the formula, replace I and N, and both ways you can find out the future values and present values. Again, these are the definitions of present value, future value, interest rate, and number of periods. That was our lecture about compound interest rate.